Okay, good morning, everybody. Okay, today we'll be going through the paper 1 of Tanjong Katong Girls School Prelim 2023. Okay, this is a very good paper, and I have actually highlighted some of the. I'll be going through some of the questions that I find quite interesting. That maybe you might want to take note at it. Okay, it will be. I will not go through all the questions, but if you need me to go through certain questions, feel free to leave a request at the comment bar below so that I'll get back to you ASAP. Okay, in the meantime, okay, let's start the review. Now, for same as before, the paper is here. I have left in the top side button here. I have left it some of the questions that you may want to take a look. Okay, these are the interesting questions that I find interesting and like quite unique. Okay, and if you've done in the paper, okay, I have actually downloaded. I actually put the answer here. So if you download the paper and you want to mark, okay, feel free to pause this video and actually mark your paper first to see which are the areas that you are wrong. Okay, now. Today we'll be going through these 5 questions, 7, 8, 9, and 15 and 18. Okay, now for question 7, let's take a look. Now, question 7 look at stabilities or what we know as CG. Okay, for this particular question, we are looking at the hammer being placed at 2 different positions. Now, the definition of stable and unstable, okay, must remember for stable, it means okay, the CG is always the lowest point already. Okay, so it's always at the lowest point. So for this case here, the moment you identify stable, you know this guy, position 1 is stable, and you know answer is B straight away already. Because why? Because for it to be stable, the CG has to be at the lowest point. Question 8. Okay, question 8 is a very classic example whereby I give you a slope with a standard dimension 3 meter, 4 meter, and 5 meter. In most of the cases, right, the question will actually ask for the work done or the work done on, well, the work done on by the friction, okay, work done by the friction, or maybe work done by the force applied itself. And sometimes it will be the work done by the weight itself, or sometimes what we known as your energy in your gravitational potential store. Okay, so in this question here, so for this type of question, you literally need to check what are the forces that are of concern to you, because the respective forces or respective energy will dictate what distance you are interested in. For example, if I'm looking at potential energy in gravitational potential store, the formula is mgh. Okay, I'm looking at the h, which is the vertical height. So even though the object, for in this case, it travel a slanted height of 5 meter. Okay, but because gravitational energy in gravitational potential store mgh, the h refer to vertical distance. So to calculate EP, I actually need to substitute 3 meter into the h, not 5 meter. On the other hand, if I'm looking for, like what the question stated, I'm looking for work done by the 3 Newton force. The 3 Newton force in this case is actually going through, is in this direction, diagonal direction. So which means that I'm also, the force that I'm looking at, work done refer to force times distance. So within the distance, I also would be looking at in the same direction as the force itself, to be in the same axis, or what I call in the same direction. So in this case, if I'm looking at work done, okay, on the force itself, okay, the formula here will be force times distance. In this case, the force I'm looking at will be 300 Newton, and the distance I'm looking at is not 3 meter. In this case, it will be 5 meter, because 5 meter is the distance that is in the same direction as the force. So that's why 300 times 5, you will get 1005 joules as the answer. This is the work done by the 300 Newton force. Distance travel in the direction of the force, okay, which is 5 meter. So this type of questions is a classic example that the marker will want to trick students into using the wrong distance. Okay, so just take note of this. Question 9. Question 9. In this case, okay, your rod is heated at one end. I would say the important word I will take note is the word metal rods. Okay, when we talk about metal rod being heated, or what we call the mode of heat transfer, we are looking at conduction. Okay, the question says conduction, and we pertaining to metal rods, metal. Okay, so if you look at metal, if you look at the concept they're looking at, is actually looking at molecular vibration. It exists in all metal. Another way that's unique to metal, solid metal, is actually what we know as electron diffusion, whereby the electrons actually absorb heat and vibrates, and as a result, he actually move faster, and it collide with other particles, okay, and hits, okay, other atoms or other molecules along the way, and this bombardment actually causes heat to be transferred at a faster rate. So in this case, if you look at metal, the concern that we are looking at, the main mode of matter that set aside matter and other solid is actually what we known as your electron diffusion. Okay, so this is the method that we're looking at. So indirectly, I'm looking at actually my answer I know is not A and B already, because one of the main unique way of heat transfer is actually what we know as the electron diffusion. Now, electron diffusion here is whereby the electrons actually move faster. And what happens is the electron are able to move when they are not bounded by their position. So that's why the moment I know this, I will know that part D is actually wrong, because part D states that the electrons will only vibrate at their fixed position, which is not true. Where only the atoms are bounded by their fixed position because of the strong intermolecular forces. The free electrons, like the word free, they are able to move, okay, anywhere and anyhow they want. And because they are able to move at a faster pace, at a faster rate, and they are small, they are able to transmit heat, the energy along the rods faster than the atoms. And as a result, heat is actually transferred from one end to the other end at a much faster rate. And this is why it explains that conduction actually happens faster in metal, as compared to plastic or non-metal. MCQ, please take note of the small subtle difference. The next question we are looking at is question 15. Now, things to take note is that this is not a parallel circuit. There's a bulk Y here. Bulk Y is actually in series, bulk X and Y. So if you are unable to identify this, maybe it's better to redraw the circuit in this way. So this is the circuit, what it look like. Okay, so in this case, I still have bulk X and Z here, X and Z. Okay, so now what I do is I actually extend this wire. This wire, I extend it, I make it longer. Okay, so the wire now will actually be here. Okay, so this is the wire I'm looking at. Okay, then after that, I have my bulk Y. My bulk Y is here. And the rest of the wire is here. So my bulk Y is here. So if you redraw the circuit this way, you'll find that actually it's actually bulk X and Z is actually in parallel, and both of them are in series with Y. So if you look at it, you'll find that the current flowing in Y is actually one of the largest, because while the current flow from here, okay, at this node here, current will split, okay, upwards to X and downwards to Z. And after traveling through Y, through X, and after traveling through Z, both wire will meet back at this node here, and they'll travel through and they will travel through Y. So actually Y, you look at the current here at Y, is definitely much bigger than the current at X and the current at Z. X and bulk Z, both are identical. I will know that because they are identical, I will know that the current they command is actually the same. So in fact, I will know that current X and current Z are actually the same current. So which means X and Z, they are actually equally bright. And which means that our answer is either A or B. The other one that I'm looking at, because I know current X merged with current Z, okay, to give me current Y. So which means that my current X and Z must add up to give me current Y, which means that, okay, so my current Y is definitely larger than current X or Z. And which means that this current Y will be the biggest among all the three current. And being the biggest current, it will mean that in this case, it will mean that the light bulb Y will be in fact the brightest. And this will bring us to answer A. Okay, so if you look at circuit, okay, it's most important to actually analyze the current flowing through the different path. Okay, to look at the arrangement of the items, the arrangement of the light bulbs, to see how different arrangement, whether it's series or parallel, how it affects the brightness. Okay, that's why it's important for circuits, okay, for you to analyze circuit questions carefully. Okay, question 18, you're looking at which solenoid will produce the strongest magnetic field lines, okay, given at the same amount of current. Now, when we look at stronger magnetic field line, it doesn't mean that the more coil it is, the stronger. Okay, we need to factor in how much is the increment in the coil. For example, if I have this coil, okay, so if I have more coil, means let's say if I want more coil, I double the coil. But the problem is that when I double the coil, I double the range. Okay, I don't actually double the strength. I just double the range. So in fact, if you look at each of the square, of the coil, these two arrangements, the coil, the strength per coil is actually the same. What I did when I used 2 coil, I increased the number of coil, double the coil. I actually increased the range. I actually increased the range of the magnetic field line, but I actually maintain the same strength. Okay, so that's why when you look at the way you phrase your keyword, that's why whenever I tell students how to increase magnetic field strength, I always tell students to actually increase, to increase the number of turns of coil per unit length. I always tell students to write this way. So which means that what they are trying to tell is that to increase the number of turns per unit length means this. It means that I'm actually keeping the length the same. So I'm actually keeping the length the same. But I increase the number of turns. Okay, so I increase the number of turns. So in this case, I actually got more turns, keeping the length of the coil to be the same. Right? So in this case, if you compare the one coil, what's the strength versus what's the strength here? Yeah, for the same coil, for the same, let's say 1 cm. For this 1 cm length and this 1 cm length, you'll find that because this is the same 1 cm length, I actually got more turns here. This is the more turns. The strength inside the 1 cm segment actually will be stronger. So in this case, I actually uses the same range, but I have a bigger strength. Okay, so this is how I increase my magnetic field strength. I actually increase the number of turns of coil. Okay, not just increase the coil. When I increase the coil, it literally means I actually increase the range only. Okay, so it's almost important when we look at how you phrase your sentence. Okay, to use the correct keywords to represent the same meaning that the marker has in mind also. So for this particular question here, I need to check for every 1 cm, how much coil do I have? For example, in 1 cm for this guy, in 1 cm, I'm actually looking at 40 coils. Okay, for part A, for every 1 cm, for 5 cm, I got 200 coils. Literally, I'm saying that for 1 cm, I actually got 40 coils inside. If for 10 cm coil, a 10 cm solenoid with 100 coil, I'm looking at 1 cm, I'm looking at 10 coils here. And similarly, for 10 cm with 200 coil, I'm looking at 1 cm, there is 20 coil here. For 20 cm with 200 coil, I'm actually looking at 1 cm is actually 10 coil. Okay, so if you look at per cm, per unit length, per cm, the number of turns of coil actually will actually correctly determine the strength of the magnetic field lines. Not how long your field line, not how long your coil is. Okay, your length doesn't dictate the strength. It's the number of coil per unit length that dictates the strength of the field line. So that's why you will know that very obviously, you know that this answer here, part A will actually be the answer because part A, you will dictate that 1 cm actually consists of 40 coils and 40 coils is actually the biggest among all the 4 options. And this will actually in fact give me the strongest magnetic field strength among all of them. Okay, so with this question here, we have come to the last, cover most of the interesting questions for this particular paper here. Okay, same thing before. If I left out anything that you want me to cover, if I mention, explain anything wrongly or not clear, okay, feel free to leave your comments in the comment bar below so that I will know and I will change or I will improve accordingly. Okay, we have come to the end of this video. I do hope the video is useful for you. At least it might have actually made your learning of physics much more enjoyable and easier along the way. Okay, if not, okay, stay tuned for my next video. Bye bye.